Almost design our finger. We have holes here and here to connect it to the hinge. We have a hole here to allow the Velcro to be threaded through. We have holes here and here to allow the string to be threaded through to allow it to flex. While flexing, the spring will be inserted here, and this back plate will prevent it from bending too far back. And the holes here and here allow for the post to be threaded through to keep it intact.
The Velcro wrist strap runs through here and is screwed into the bottom. Another strap is screwed in here. It runs across the palm of the hand and will meet the hand flap, which would be attached here. The top hole is for the string to run through, and the two holes here are for the hinge to screw into. The top screws into the top plate, and the middle hole allows for the string to run through. The bend in the hinge goes over the nub, and the bottom screws into the bottom finger segment.
Okay, as for the moving parts of our design, we have 3 moving parts, 2 of which are on the finger, and it's going to allow for that natural closing of a finger. And that's done through a string which is fed into each part and then connected to the wrist. And if the wrist is moved down, the finger will close. If it's just linear, it'll stay open. The third moving part is the actual flap, and that just allows for linear movement to just kind of accommodate to hand position and just help with overall comfort. And here are our moving parts.
We ran our simulation with a force applied over here. According to the von Mises stress value, the hinge is most likely to break within this region of color, corresponding to this area of the hinge right here. And this is due to our material of choice, ABS, and its yield strength. In building the first prototype, the hinge actually did end up breaking right here, just as the simulation predicted. Moving forward, we stuck with ABS for our reprint due to limited time and materials, and made this area of the hinge a bit thicker since last time it was too thin and ended up breaking.
For our initial design, each of our parts were modeled off the dimensions of a wooden hand. Once each part was created separately, we were able to put them all together to accommodate for each other. In the beginning, our biggest issues were thin structures that led to breaking and a lack of clearance because of high tolerances. We tried fixing these issues when redesigning. For our dimensions, as stated earlier, we were able to utilize a wooden hand to act as our model for the project. Our flap and base plate contained gaps to thread our Velcro wrist straps through. For the future, we now know to be especially careful with our tolerances to make sure that fabricated parts can fit smoothly without friction.
During the design process, we utilized a small wooden hand off of Amazon to not only build our prototype off of, but to also use it as scale and proportion. We utilized screws from a watchmaking set to choose our hole sizing to downsize, and we also utilized SolidWorks to design each part in assembly.
Inclusiveness, time management, cooperation, and open-mindedness were all important teamwork skills that kept us on track with deadlines, allowed for each member to have input on bettering the design, and ensured that we were all on the same page.